video, we're going to take a look at some practice problems with linearization. Recall that there are two basic reasons why we would linearize. One is to find the mathematical relationship. So we don't know what these two quantities relationship is, and we're looking for the graph to show us. And the first two are this type. So the first one, it's clear that the voltage is proportional to current. It's a linear relationship. So we could say that voltage, the relationship between voltage and current is linear. My pen's not working. Let me try again. There we go. Or we could say the relationship is the voltage is proportional to current. Let's do I as current. So that says that if one doubles, the other doubles, and so on. The second one is giving us the graph of the period of oscillation of a mass on a spring and the mass. So we can say that's a T versus M graph. And it's clearly not linear. So what we need to do, this is showing us a square root graph. It's likely a square root graph. So we would try to linearize it by graphing T squared. So all of that data for period, we would square every single one and graph that on the y-axis and mass on the x-axis and look at that shape. And if that relationship is a square root, then it will become linear. So the mathematical relationship is T squared is proportional to M, and that would be the mathematical relationship. All right, now the other thing is sometimes we will have a known relationship and we want to find a specific quantity. So the 3, 4, and 5 are examples of this. And so step one is find the equation that models the situation that you're dealing with. Okay, and then find the constant that you want to find. So we want to find speed. It's moving at constant speed, and that's what we want to find. Okay, so we're going to take the equation, and we are going to manipulate it so that we can put it in the form of y equals mx. So in this case, it's already kind of set up that way. We have kinetic energy in the y position, and we have we can just switch the v squared over here in m. So now these things are all the constants. Mass is changing and kinetic energy is changing. And so we can graph kinetic energy on the y-axis. Our slope is going to be 1/2 v squared. And then we can have mass on the x-axis. So kinetic energy is like that. And then our slope is going to have, it's going to equal all of the things in the equation that are constant. So 1/2 v squared. So what would the speed be equal to? The final step is then solving this for speed. So 2 times the slope, whatever that numerical value is, and then you would take the square root of that, and that will get you the speed. All right, let's take a look at the fourth one. So the equation is that models the situation is the spring force equation, which we call Hooke's law. All right, so I'm going to write it out. And what is the constant that I want to find in this experiment? We want to find the spring constant K. So that is going to be the constant. So we're going to change this equation into the format of y equals mx, putting one of the variables on the y-axis and one on the x. So we could put the spring force on the y-axis, that's in the y position. We could put the stretch or compression, delta x, on the x position, and then whatever's left over that's not changing is the slope, and that's just going to be the inverse of k, or the opposite of k, I meant to say. Okay, and so we will get a slope that is equal to the opposite of k. So because it'll probably create a graph like that. So now the opposite of that slope is equal to k. There. Hopefully that makes more sense to you. Reason why is because if you stretch a spring in one direction, the force is in the opposite direction. So that's what that negative sign represents. All right, last one. We want to find the centripetal acceleration of an object. So that is going to be the constant. And we have multiple measurements of v and r. So let's write down the equation. And let's highlight the quantity that is constant that we want to find. And so we're going to have to manipulate this equation so that we put it in a y equals mx type format. So let's multiply both sides by r. And so we can have v squared equals ACR. So we can have v squared graphed on the y-axis. We could make r be on the x-axis, and then our slope can be the centripetal acceleration. So v squared and r, and then the slope is equal to AC.